Welcome to Understand the Math. In this problem, we're given a matrix A, and we're asked to find an orthogonal basis for the column space of matrix A. And then we're asked to find a QR factorization of matrix A. To find an orthogonal basis for the column space of matrix A, I'm going to begin by taking the columns of matrix A and assigning them to a vector. I'm going to let x1 be our first column, so that's 1, 0, 1. I'm going to let vector x2 be our second column, 0, 1, 2. And then lastly, I'm going to let vector x3 be our last column, 2, 1, 0. Our orthogonal basis, I'm going to name with the vectors v1, v2, and v3. We are going to use the Gram-Schmidt algorithm to find these orthogonal vectors. Our formula for v1 is just equal to x1. So that's just because we're going to take our first vector and we're going to hold it fixed. And I'm going to go ahead and put what this is equal to. So this is our 1, 0, 1 vector. Our second vector, v2, we're going to make orthogonal to vector v1, and we're going to do that with this formula. v2 is going to be x2 minus x2 dotted with v1, all divided by v1 dotted with v1 times v1. This is going to be vector x2, which is 0, 1, 2. And we're going to subtract x2 dotted with v1. So let me go ahead and let me highlight these so we can see what we're dotting. Let's see here. That's our x2, and that's our v1. So we're going to take those dot products. So this gives us a 0 plus 0 plus 2. And then we're going to have v1 dotted with itself, which is 1 plus 0 plus 1, times our v1, which is 1, 0, 1. One thing I like to do when I'm doing the Gram-Schmidt is I like to do this and then say what it's equal to. So we have a 2 over 2, so that's a 1. So when we subtract these two vectors, we're going to get a minus 1, a 1, and then a 2 minus 1, which is 1. And that's our vector v2. Let's go ahead and highlight that vector because we're going to need it later. And right above this in red, I'm going to write down v2. Let's now find v3. The formula for v3 is a little bit longer. It's going to be x3 minus x3 dotted with v1, all divided by v1 dot v1, times v1, and then one more. We're going to subtract x3 dotted with v2, all divided by v2 dotted with v2, times v2. v3 is going to be x3, which up above is 2, 1, 0, minus x3 dotted with v1. So that's going to be these purple vectors up here, x3 dotted with v1, which is just x1. So we're going to pick up a 2 plus a 0 plus a 0. So we'll write that down as 2 plus 0 plus 0, all divided by v1 dotted with itself. That's this other purple vector, and that's going to be a 1 plus 0 plus 1, and that multiplies v1, which is 1, 0, 1. Now we have one more dot product to do. That dot product is going to be x3 dotted with v2. So let me go ahead and let me highlight x3, just like we did v2. So we're going to take those two dot products. That's going to give us a minus 2 plus a 1 plus a 0. Let's write that down. minus 2 plus 1 plus 0. And then v2 dotted with itself. That's our yellow vector up here on the right. So that's to give us a 1 plus 1 plus 1. And then we have our vector v2, minus 1, 1, 1. The biggest mistake I see students make, and that I've made as well, is this vector right here. Make sure that that vector is v2 and not v1. Now let's go ahead and let's see what our dot products give us. This dot product is 2 over 2, so that's equal to 1. This dot product is a minus 1 over 3, so all of this gives us a plus 1 over 3. That will help now when we go ahead and add these up. Our v3 is going to equal this. We're going to have a 2, and then we're going to subtract a 1, and then we're going to subtract a 1/3, and then we're going to have a 1 minus a 0 plus a 1/3, and then we're going to have a 0 minus a 1 plus a 1/3 again. When we add all these up, let's see what we get. 2 minus 1 is 1, minus a 1/3 gives us a 2/3. And then 1 plus 1/3 gives us a 4/3. And then a negative 1 plus 1/3 gives us a minus 2/3. Let's now write our answer down below. The orthogonal basis for the column space of matrix A is going to contain these vectors. V1, let's see if we can find that. That's 1, 0, 1. And then V2, that's over highlighted up in yellow, minus 1, 1, 1. And then the one we just computed. 2/3, 4/3, and a minus 2/3. And that's our final answer. One thing that's really nice when you use the Gram-Schmidt algorithm is that you can check your work. All you have to do is look at these vectors and double check that they are all orthogonal to each other. Let's now find the QR factorization of our matrix A. We're going to write matrix A as Q times R, and our matrix Q is going to contain the vectors Q1, Q2, and Q3. And I've written the formula for these. Q1 is just V1 that we found in part A, divided by the magnitude of V1, and then a similar formula for Q2 and Q3. So matrix Q is made up of vectors that are orthogonal and orthonormal because their magnitudes are all equal to 1. All we have to do to find matrix Q is we're going to have to find the magnitudes of our V vectors. I'm going to start by writing down our V vectors that we found on the previous page. Our V1 was equal to 1, 0, 1. Our V2 was equal to minus 1, 1, 1. And then our V3 was equal to 2/3, 4/3, and minus 2/3. Let's go ahead and let's compute their magnitudes. The magnitude of V1 is going to be the square root of 1 plus 1, so that's root 2. The magnitude of V2 is going to be the square root of 1 plus 1 plus 1, which is 3. And then for the magnitude of V3, we're going to have to write some more stuff down. This is going to be the square root of each component squared. So that's going to be a 4 over 9 plus 16 over 9 plus another 4 over 9. And this is equal to the square root of 24 over 9, which we're going to write as the square root of 4 times 6 divided by 3 times 3. So we can see that this is going to be 2 root 6 over 3. Now let's go ahead and let's write down what our matrix Q is. Our first column is going to contain V1 divided by the magnitude of V1, which is root 2. So this is 1 over root 2, 0, and 1 over root 2. And then V2, we're going to divide by the root 3. So we have a minus 1 over root 3, a 1 over root 3, and then a 1 over root 3. And then our last one, we're going to have V3 divided by that number. So let's see here. When we divide by this number, we're going to multiply by 3 and divide by 2 root 6. And we're going to multiply V3 by this. So let's see. Our 3 and our 2 are going to cancel, and we're going to have our 1 over root 6. And then we're going to have a 2 over root 6. And then lastly, we're going to get a minus 1 over root 6. I'm going to highlight this because this is the matrix Q. That's part of our factorization. Now let's go ahead and let's find R. To find R, we have to know a formula, and that formula is that R is equal to Q transpose times matrix A. Our matrix R then is Q transpose. Now, when you take the transpose of a matrix, the first row becomes the first column. So this is 1 over root 2 minus 1 over root 3, 1 over root 6. And then our second row is going to become our second column. And then our third row is going to become our third column. And this gets multiplied by our original matrix A, which was 1, 0, 2, 0, 1, 1, 1, 2, 0. Now all we have to do is go ahead and multiply all of this out. We're going to start by multiplying this row by this column. So we're going to get a 1 over root 2 plus a 1 over root 2 is going to give us a 2 over root 2. And then we're going to go ahead and multiply the top row by this column. And that's going to give us a 0, and then a 2 over root 2. And then we're going to multiply by our third column. And that's going to give us a 2 over root 2 plus a 0. So that's just 2 divided by root 2. Now let's go ahead and let's work on our second row. We're going to multiply that by our first column, and we're going to pick up a 0. And then the next one, we're going to get a 0, and then a 1 over root 3, and then a 2 over root 3. So that's going to be 3 over root 3. And then lastly, we're going to have a minus 2 over root 3 plus a 1 over root 3 gives us a minus 1 over root 3. And then let's look at our last row. For that row, we're going to get a 1 over root 6 minus a 1 over root 6, so we get a 0. And then we have a 0, a 2 over root 6 minus a 2 over root 6, so that's another 0. And we got one last term. That's going to be a 2 over root 6 plus a 2 over root 6. So that becomes a 4 over root 6. And we can actually simplify this. So I think we should take just one more minute and let's do this. 2 divided by root 2 is root 2. So we have root 2's up on the top. And then we have a 0, and 3 divided by root 3 is just root 3. This one we can leave the same. And then the bottom row we can leave the same. And this is our matrix R that's part of our QR factorization. Notice that a built-in check is that matrix R is always an upper triangular matrix. And so you can always make sure that you did it right if you get zeros below the diagonal.
If this video has been helpful to you, please consider subscribing to my channel. Keep believing in yourself and have a great rest of your day.